Okay, so let's look at soil classification, and it's based on all these components that we talked about previously on this, and then you can divide the world up into these different regions based on the soil type. And again, it's related to all these things: the geology, geomorphology, time, and climate, and that can affect the type of soil that you have in different parts of the world. Now, and we call this soil taxonomy, where you create these different classes of soil. And this is done, the United States has what we call a soil classification system, where you go out into the field, you observe the soil appearance and impedance, and then you decide what type of soil it is, and then we create maps based on these soil regions. So go over and watch this farming, this soil video in the module on farming, and it will show the importance of this, why it's so important for agriculture. So here's the different types of soils, and here's their distribution over the land on the surface of the earth. Okay, so, and I'm going to go through these quickly on each one, but they're also in your book. But at least for us living in the United States, you might want to familiarize yourself with the ones in our country and where they are, especially the Eutasols here in the southeast, the Iridosols here in the southwest, the Mollisols, which are kind of spread in the northern half of the continent, and the Alphasols, which we see over here in the Midwest. Notice over here, in our desert areas, we have what we call the endosols. In rainforests, we have oxasols. Okay, so all these different types, and we'll go through them kind of quickly here. Now, all these things can affect what we call the pedogenic regimes, where you have mineralization, leaches nutrients out in humid and warm climates like your oxasols. You have calcification, where you get a horizon rich in calcium carbonates. You'll see this in arid lands. Salinization, where you have high concentrations of salts and higher evapotranspiration rates and aerosols. Polarization, which is movement of iron and aluminum oxides. They're usually in forest and cool climates. The spatosols, gization, which is where you have humus, like water saturated soil horizons, and you'll find that in cold, wet climates. The deltasols. So here's your oxasols again in the tropics, because again, you have humid and warm climates that leach out the nutrients. The mollisols, which are right here. They didn't talk about it here. So these are the ones that you'll find in your tropical arid grasslands and forests. Again, not in your deserts there, of course, because of the lack of moisture. So mollisols, alphasols, and then your oxasols. Now, notice they're not necessarily good for agriculture. The mollisols are, but this just means that again, you have this high level of leaching, where the nutrients in silica are dragged down through the horizons because of accumulation of moisture. So oxasols, again, high temperature, high rainfall, equatorial latitudes, well developed, usually reddish or yellow, lateralization, and poor in organic nutrients because of this. So you rely heavily on the recycling of nutrients. And again, this is from your book, so just as you get more moisture, it goes down through the soil, pulling the nutrients down to the water table. Iridosols, it's the largest soil order, and that's going to be a question on your test, I'm almost sure. Pale or light color near the surface, very shallow soil horizons, and they're iridosols because they lack water and vegetation, and you see higher levels of calcification and salinization. Now, there will still grow things because you do get some moisture, okay, but your potential evaporation will exceed the precipitation. So moisture carries down, but then as the land heats up, it evaporates, it's pulled back up and will deposit materials, the accumulation of calcium carbonate there in the soil horizons. Moss soils, again, they're great for agriculture, especially in the grasslands. The horizon is very dark with organic surface layers, and it's very soft. And these are what you'll find in the steppes and the prairies. So notice how deep the organic layer goes down. Oftentimes it's not nearly this deep. Alpha soils, they're weathered forest soils, very widespread and very fertile, but again, it depends on the moisture and the temperature. You're going to get a clay horizon with those because of leaching by precipitation. Now compare this, see how shallow this is compared to the organic layer here. Okay, so just a way that scientists go out and they use these horizons to classify the soils. So shallow soil here in Wyoming, alpha soils here in Indiana. So again, in the great prairie regions of the United States and Canada, you get short grasses and you get tall grasses. And again, it depends on the soil type. Tall, best in alpha soils down here. Short grows in the iridosols that we see here. And again, you're going to get more precipitation over here. And so that increases or changes the soil type. Your weathered forest soils, young soils, entosols, eudisols, spilosols, and septisols. So again, that includes your desert areas. Here's kind of on the periphery of the rainforest and down in the southwest portion of the United States and over here in all of Southeast Asia. The septisols up in the northern regions and in Europe. Eudisols are heavily weathered forest soils. They have residual iron, so they're red. More leaching because increased precipitation, but they're important because they respond well to good management. So, you know, here, if you're being careful with it, they're very good for growing, for agriculture. Again, if you manage it well. Here's an example. So notice the reddish soil there. But again, pretty good for growing short-rooted crops. Photosols we see in the coniferous forests in the north. And again, the soil tends to be a little more sandy. And you get organic materials from the top horizons and they're deposited down into the lower horizons. And they're not good for farming because it's very low pH, but it is good for temperate forests. Especially see these where you get moist, cool climates like on the east or the west coast of Canada. Entosols are undeveloped and fairly recent. You see them in a lot of climates, but they don't have a lot of horizons, and so they're not very fertile. And septisols are also weakly developed ones. It's the next stage after, so entosols is first, then it's that. And again, a lot of times it's glacial till. You can see where those are. And our cold and volcanic and organic material or organic matter soils way up in the north, and then often where well, I'll show you this on the next slide. The vertisols were higher elevations. So the gelisols are the ones that contain permafrost, and those are at high latitudes, higher elevations. And they can store large amounts of organic matter, and they contain about half of the global carbon. And so you get these really thick O horizons. Okay, like this. So in the summer, where we get some warmer temperatures, anaerobic green, a lot of times is underneath that. So notice all the organic material there, but it's generally frozen. It only thaws out, down just a few inches during the summer months. You have your volcanic soils, which again, they're very unique, but they're also incredibly fertile, especially when you mix it with water. I'm going to go back very quickly, but notice, here in the Rift Valley of Africa, for example, and you'll see them over here in Australia as well. They're going to have A horizons, heavy in clay, for example. The histosols are organic ones. They're generally found in former lake beds, and they've been saturated for long periods of time, and you get what we call oxygen-free anaerobic growing conditions. And this is your wetlands. The vertisols, again, very high in nutrients, and they're really good farming soils. So you see population clusters in the valley in Africa. So again, this is from your book, so kind of pay attention to it. So we'll stop there and do energy pathways and